Hi everyone, welcome to the third video in Unit 2. We're going to talk today about piecewise functions. You can see the objectives there, evaluate a piecewise function and also graph them. So what is a piecewise function? Well, a piecewise function is a function that's made up of two different pieces. For instance, this is a constant graph, but if you'll notice it ends here, it's a piece. The other one begins where that one ends and continues on. It's a different line with a different slope. And so you can see here that this is the function. It's a piecewise function, but it consists of two pieces. And then there are two parts here. So this part is the domain of the function right here. So where x is less than -4, so I come here where x is less than -4, there's an open circle and this line. Where x is greater than or equal to -4, so that's why this one is closed in, and then to the right, then it is this function. So this part right here, these are the intervals, not written in interval notation, but it is an interval. And then this is the equation of the function in those intervals. All right, so that's what this looks like. Now, if I were just to graph 2x plus 10, we would know that that would be a line, an entire line, right? And this line, if I continued it on, would cross at 10, because 10 is the y-intercept, and then the slope is 2. This is the line y equals 7. It is a constant line, which means if it went on infinitely in both directions, it would pass through 7. To evaluate a piecewise function, and you'll recognize this is the same one from the previous page, we would be given this information, and we would say f of 0, find f of 0. So we're going to put 0 in where there's an x in the function, just like we've used function notation before. And so what we need to do is find which piece has a 0. Now you can do this graphically as well. So I'm going to come down here to the graph and I'm going to say 0, x is 0 here. What is f of 0? Well, f of 0 would be the y-coordinate, which would be 7. So f of 0 is going to equal 7. Now, if I use just the equation, what I would do is I would find the interval right here where 0 is a part of the interval. So I'm looking here, is 0 less than -4? No. X is greater than or equal to -4. So, because this is a constant, it would be 7. All right, so another thing you could ask is what is the value at where it breaks, where the two pieces come together. So at -4, so here at the graph, I look at -4, that's an open circle. This is a function, so you can only have one value, and it's here at 7. So f of -4, right, -4 is in this domain, and it would equal 7. So where is -5? Well, I come here and I look on my graph. I look where x is -5 and y is 0. So I come up here and I just double check. If I put in -5 is less, so it fits into this domain. When I put in 2 times -5, I get 2 times -5 plus 10 is -10 plus 10, which is 0. So you can see both using the equation and using the graph, I can evaluate a piecewise function. To graph a piecewise function, we're going to use the same pieces and graph it that way. So what we're going to do is begin, and I call these training wheels because we're going to use this to help us graph. So when you look here at the domain, you can see that we have one function if x is less than or equal to 3, and we have another function if x is greater than 3. So I'm going to find where x is 3, which is right along here. And I'm just going to put in, if I can get it to work, I'm just going to put in like a little line here. So on this side of the equation, where x is greater than 3, it's going to be equal to -1. And on this side of the interval, it's going to be x minus 1. All right, so we're going to graph both pieces. So starting here at 3, we notice that in this interval, this line right here is going to get the closed circle, and this is going to be the open. So I'm going to go at 3, and -1, and I'm going to put an open circle. And then it says where it's greater, that is -1. So I'm going to draw the line, y equals -1, but just to where the interval ends. Okay, on the other side, what I'm going to do is graph this line, x minus 1. So I'm going to go to -1, right? Just like I'm graphing a line, and the slope is up 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1. And at the interval, because there's an equal sign, it actually has a closed circle. So I'm going to connect the dots, and that's my piecewise function. Now, this is not a continuous. It's not continuous. In other words, if I were to follow along with my pen, I would have to pick it up here at 3 because there's a jump. We often call that a jump. So the other part is the domain and range. So there are different ways to write the domain and range, but basically, because this starts over here to -infinity, and this goes to +infinity, and there is no gap there in the x values, I could say that it was all reals. And so I've seen that before where you do all reals like this for the domain. Now the range, on the other hand, the range starts at -infinity and ends up at 1, 2, ends up at 2. So the range is going to go from -infinity to 2, and it's going to include 2. This is the absolute value graph, and we know it's V-shaped. We've done some transformations with this. But I've also wanted to point out that this is a piecewise function. Okay, it consists of 3 pieces. So here at 0, 0, right, is a single point. So where x equals 0, y equals 0. Done. Now, to the right of that, this part right here, to the right at 0, and we can see that, right, it kind of changes right here, those training wheels again. This part over here is a line. It's the identity line, y equals x, right? And over here, this line on this side is another identity line, but it's been reflected over the x-axis, so it is -x. So you can see this absolute value graph actually uses is a piecewise function, and you can see it here. Be sure and write that in your notes. So here is just a quick multiple choice thing. Remember what the absolute value graph looks like. We've done a bunch of transformations. We know that originally the graph of absolute value is centered at 0, 0, over 1, up 1, over 1, up 1. So this is what the basic graph looks like. All right? So how was this moved? Well, from this point to this point, it moved 1 unit right and 1 unit down. All right? So we look here and we're looking, this has down, this is down, and this is down. C does not have anything that goes down, right? When you put the -1 on the outside of the function, that's down. So here, we're looking here, and that doesn't move right or left. Can't be that. So we're now down to B and D, the negative or the positive. And remember that the positive inside is left, and this one is right. And so we want 1 unit right, 1 unit down, and that's going to be B. Okay, I want you to copy this down in your composition notebook and graph it. I want you to try graphing it. It's a lot like the example that we did earlier in the video. So I want you to use the training wheels. I want you to go ahead and graph this equation. Identify the domain and range, and we will talk about it when you come to class. See you then.